let's get into the big topic of open source, something that we actually say at Red Hat.
We haven't
This is so awesome.
We are an open culture that
It's actually a big piece
what
of
is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed.
Hello, good morning, good afternoon, good evening, wherever you are in the world. This is the Ask an OpenShift Expert live stream, episode 168. Sully, how you doing, man? It's been a while.
I'm good. It has, and I am feeling immeasurably better than I was last week. Last week I was so hopped up on decongestants and cough medicine and everything, I wasn't sure like which state I was in. So
Yes.
I feel a lot better this week. I feel more aware and not cloudy and foggy.
Yeah, I feel like we've swapped places then, because I'm on the upswing, but I'm still down kind of hard. Like, it's not good. So
You and I, we were chatting in Slack earlier, and like like this year there seems to be something going around. Like my son he's down hard right now because he's got like we don't know if it's flu, we don't know if it's like RSV, we don't know what's going on, but he feels like crap. So,
yeah, that sucks, man. Yeah, so my daughter was out of school, and so we were gonna go and do some local things around here. Both of us laid up, can't do anything, both sick, just miserable. So
yeah. Well, for anybody who's not feeling good, hopefully it passes quick. I'll say my wife had a sinus thing that she passed to me, and it went from viral to bacterial. So I got some antibiotics literally the day after our stream on Thursday, and within 24 hours I felt significantly better. So
that's where I'm at, man. That's where I'm at. I'm afraid, but it might be what I have to do.
So yeah,
cool.
Anyways.
Cool. Well, hey, so we've got Chris Butler with us today. Chris, you want to give a quick introduction?
Yeah, so I'm Chris Butler. I work in our field CTO office in APAC at Red Hat, and I've been spending a lot of time with lots of our clients across APAC and now globally talking about confidential computing and some of the security technologies around OpenShift.
Nice. Awesome. Yeah, so we inadvertently are doing this little security kind of series again, where we had the RH people. Then last week we had virtualization UX, and then now we've got you here with COCO, and then next week I think we have Conforma, which is an extension of the RH stuff that we did a couple weeks ago. So it's kind of cool that we've got these big broad scope topics going on. So let's do a top of mind real quick. For me, it's really just the schedule. So we have Conforma next week, and then I just do not remember who's coming the week after. And then we have KubeCon coming up the week of the 23rd. And then we've got Jonathan Gershatter's team, and they're doing like it's a bunch of different topics over the course of a few weeks. So it's going to be pretty interesting. A bunch of AI focused things, some virtualization focused things. So it's going to be a cool way to close the quarter down and then swing back into summit season. And Sully, I know you've got a couple things.
Oh, summit's coming up quick. I'm looking at my Slack over here, and I have several unread things, and it's all related to Summit, and sorting out like what demos we're going to have and what labs are going to be going on and who has sessions that are accepted, and it's Summit's already in full swing. I don't remember if I said it here on the stream or if maybe I told you, Johnny, I was at Red Hat 1, and like we're figuring out labs at Red Hat 1, and then literally I went from one table to another table at the conference center, and we were talking about labs at Summit.
Oh, wow.
So it's like back to back and nonstop. Top of mind. I had two things that I wanted to talk about. I'm going to share my screen real quick here. Make sure I get the right one. So at the end of last week's stream, we had somebody who was on chat or on the comments there who was saying that they had encountered a bug with OpenShift virtualization in the UI that resulted in them accidentally deleting like 200 virtual machines, which is clearly a bad thing, right? I come from the storage industry, and the storage, rule number one is you never lose data. So accidentally deleting 200 virtual machines is kind of terrifying, right? Under the best of circumstances. So I did a little bit of research after we ended the stream, and then immediately had a call with the product manager and folks in order to get them involved. And here's what I found. So what I believe happened in that person's instance is When we look at the tree view here, right, and let me collapse this. I have this big list of virtual machines that are running inside of my cluster. And if I click on one of the branches, right, I have my list of VMs. I can do things with these VMs, like I can select them, and I can do things like, hey, I want to stop these virtual machines, right? And everything is great. But if I come back up a level, you'll notice that these stay checked. So if I have a large number of virtual machines, enough where this scrolls off, maybe I have multiple pages that are listed here and something like that, these never become unchecked. So if I select other VMs here, and then I wanted to delete that VM, right, that would then result in these other ones that had already been checked being deleted. So that's what I think happened, is there's a bug where when you move off of these, change them. Like I can come here and I can say, so see how this one that I selected at the top level is already checked? When I'm looking at the branch, I only operate within what's on the branch, right? So if I come here and I go to stop this one, right, so that's stopping. If I come back here, notice both of these are still stopped. So I can select these and I can go to start. So remember Fedora demo, I did not uncheck. So I click start here, both of these are starting, right? This one up here is still stopped. Within the branch, it operates as expected, aside from leaving the check marks checked over time. But again, if you go up a level, you see that everything stays checked. And I think my actions, my delete is missing from here, because probably because there's still some that are running or something like that. But one important thing to point out. So one, absolutely, you definitely want to be aware of that. Be careful what you're clicking on, right? Be cognizant of what checkboxes are checked. You can do this thing and unselect all of them. Another option is if I go to my overview here and I go to settings and virtualization features, general settings, and then I go to virtual machine actions confirmation. If I turn this on, it should ask me to confirm when I want to do things like delete a virtual machine. So if I come here and select this guy and go to stop it.
So Sully, is that off by default?
It is off by default, yes, or at least
Okay.
cluster. If I go to delete, see now it pops up a thing saying, are you sure you want to do this? Whereas if I turn that off, and we could go back and look at what that looks like here. If I turn that off, so we'll turn that, then we'll go back to virtual machines, and we'll go back to build 9, and I go to delete. Well, it made a liar out of me, but anyways, it made the meter read login or something like that. But anyways, it would historically it doesn't ask you for confirmation. It YOLOs you into that action. So be aware of that. Be cautious. Be careful when it comes to those things. For that particular person who experienced that, sorry. I know that that's frustrating and upsetting, and I hope that you were able to recover from that with as little drama as possible. But please be aware, definitely, that there's a bug open against that. I don't have the link handy, and they are working to address that as soon as they can. The other thing that I wanted to bring up is the migration toolkit for virtualization 2.11 released yesterday. So kind of some big things with MTV. One, if you're not familiar with MTV, it is not music television. It is our tool that you use with OpenShift virtualization in order to bring VMs into your cluster or into your OpenShift virtualization environment. So if I go to create migration policy, right, this is what I would be using to do that. I don't know why it's not showing up here. Let's go to our core platform, migration. So this is our MTV interface. If it loads here, right, I connect it into, pointed at my existing virtualization infrastructure. You can see I've got VMware and OVA. I can import OVAs using the tool, OpenStack, Red Hat virtualization, and other OpenShift virtualization clusters. Once I've pointed at a existing infrastructure, I can then go in and I can tell it, hey, import virtual machines. So this works in kind of 3 or 4 different stages, or what's happening behind the scenes. One, when I say I want to import this VM, you have to account for the geometry of the VM. So things compute, right, storage, memory, etc. the networks for the VM and the storage for the VM. So the geometry is easy, right? Oh, the VM on the source side is 2 CPUs and 4 gigabytes of memory. I'm going to create a VM that's 2 gigabytes and 4 CPU, or 2 CPUs and 4 gigabytes of memory on the destination side. Network is similar. You say, oh, the source network is, port group 123. The destination network is, network attachment definition or cluster UDN 123. So storage is where it gets interesting, because historically what happens is it copies that source disk into a new PVC. So if I have a 100 gigabyte disk, maybe it's thin provisioned, so only 50 gigabytes is in use, it copies 50 gigabytes of data across. So that means it's being read from the source system, copied across the network over to the destination OpenShift virtualization cluster, and then written to the underlying PVC. 2.11 introduces storage offloading as generally available. It's been tech preview for a release or two, but now it is generally available. So storage offload migration here. What it does is underneath the cover, it coordinates with the backing storage system and uses Xcopy in order to offload that storage migration process. So for storage systems that are supported, this means that it reduces that copy time significantly, right? I'm no longer having to do a copy across the wire. Instead, it's using whatever tools within the storage array in order to do that. Just be aware, like with all Xcopy operations, it only works within the same storage device or storage array, depending on how your storage is implemented. So if I'm copying, my source is running on a NetApp system and my destination is running on a Hitachi system, right? I can't X copy between those systems. There's no linkage between them at the backend level, so that's still going to be a traditional copy. But if both source and destination are the same NetApp system, it offloads it. So it's
awesome.
Really cool stuff. Yep. Other than that, I think that was all that I had for anybody who's interested. Chris actually brought this up in the pre-show before we started the stream, which is Red Hat Enterprise, or Red Hat AI Enterprise is now generally available, and alongside of that, Red Hat AI Factory with NVIDIA is available. So for anybody who's interested in those things, it's basically this is how we, if you remember, not too long ago, we announced day 0 support for the newest NVIDIA architectures and capabilities. This is how we're implementing that. So it includes RHEL for NVIDIA and a number of other things, and a really nice packaged, I don't want to call it a reference architecture, but it's also not a reference architecture, it's a solution in order to do all of those things. So definitely check that out if you're doing anything AI related, whether it's model building, inferencing, any of those things using NVIDIA technology.
And having looked into this, there's just so many things to configure in NVIDIA land there to get the optimization right. It's a real accelerator. But for me, I think it's just the start. I think there's some really cool work that's been going on, which is tech preview on supporting the DPUs, which are these high-end, multi-$1,000 NICs that they put in the NVIDIA boxes, and how we can have OpenShift offload all the networking stack onto the NICs, so we actually get the full performance of the hardware all the way through the stack, which has been really awesome as well.
Yeah, that's awesome. Cool. No, thanks, Sully. Appreciate it, man. Thanks for going through that. And to the person that deleted all those VMs, I'm sorry. I'm laughing because I've done something similar, and I feel your pain because I know what that feeling is, and it hurts. It hurts real good.
I've done it too. I may or may not have one time used Power CLI and accidentally removed all the data stores. Which, wow, is that that's a scary feeling.
Yeah.
When several thousand VMs suddenly all go into an unknown state, and I know that I have to go back and at best restart all of them.
Yeah. It's like, I'm sorry, team. That was me.
Yeah.
As long as it's not Friday afternoon after a long lunch.
Well, that's the only time to do it, honestly. If you're gonna mess with production, it's Friday at 4. That's it.
Don't do the was it Mad Men, the 3 martini lunch. You know, that's not when you want to be making changes.
Absolutely, it is. Cool. All right, Chris, let's kick it off, man.
Yeah. So thanks for having me on, guys. I think this is like a really cool time to be talking about some of the confidential computing capability, because we're starting to hit this inflection point where it's a lot more generally available. When you look at the hardware that people have in their enterprise data centers, it generally supports it all of a sudden. If they have like, recent in support hardware, then you can use confidential computing. So I think the first one really is just to kind of say, what is confidential computing? So like everyone knows that, you put something on the cloud, you encrypt data at rest. You transfer data between 2 different services. First thing you have to do is screw around getting TLS certificates in place, or you use Istio or something similar to kind of encrypt the data in motion between 2 different services. Like that's a must-have everywhere. What we all know as well is that you have data in use and it is vulnerable. So, often we think about virtual machines as that protection layer, but I'm sure Sully can go into the details and say, if someone gets root on the OpenShift node or in any hypervisor, all they have to do is do a core dump and they see all your memory. And in the end, eventually that means, the connection from the hypervisor to the SAN, even if the SAN is encrypted, is in the clear. Like it's just inevitable that you need that device pathing in there. So whenever someone can get access to the underlying infrastructure, everyone's in trouble. So what really has been happening is this like hardware evolution that's been going on, called Trusted Execution Environments. So there's an organization called the Confidential Computing Consortium, where it's standardized, and it's really been enabled by most of the hardware vendors already. In various levels. So TEs are designed to protect data and use. They do that through encryption. So effectively, just think the easiest way to think of it is if I'm root on a machine, there's an enclave of data inside that TE and I can't get access to it, or it's encrypted. And effectively, the way that is done is by using a set of special APIs. Now, that means that hypervisor might be your hypervisor in your data center on-prem. It could also be the hypervisor of a cloud provider, which a lot of people are interested in as a use case of like, I don't really trust the cloud providers. There's obviously reasons for that. And it doesn't necessarily need to be geopolitical. It just can be, I don't really trust the cloud provider because, I'm in retail and they're in retail as well. I don't want them to get access to my data. It could be just so that you really understand what's going on. So that's the kind of mechanism that we really want to enforce. But the question is, if I'm doing and when we do that, what we need is these hardware extensions. So think of it this way: is I need to trust something to execute security. You always need to have some trust. So what we're trying to not do is not trust the operators, because humans and corporations, they're exposed to doing silly things. So what we want to be able to do is to anchor it in something which is really hard to change. So in the case of the TE, they basically execute it inside the chip. So Intel, AMD, IBM in the mainframe, ARM are starting to do this. Unfortunately, it's not on our Raspberry Pis yet. It's in ARM Spec 9, so hopefully it's coming. AWS do something very similar in Nitro. And they put hardware extensions. So the only piece of code which we really have to trust is some of the microcode going on inside of the chip. So just to provide context, like when you make these chips, they actually burn in private keys into the chips so that you can sign information. So that's kind of some of that hardware isolation is what's really required. So the chip basically manages the enclaves and divides up the memory and encrypts the memory with different keys within the infrastructure. So for Red Hat, we kind of do a couple of different things. We do confidential VMs. A number of the cloud providers support confidential VMs. So we can be that OS with RHEL inside of it. So you can spin up a confidential VM on Azure, GCP, AWS, and dump a RHEL instance in there. and it can be protected once it's in there from the underlying platform. We're also working on something called confidential clusters, which really only applies in the public cloud, which is I want to protect the entire cluster from the cloud provider. It's something you have to set up. Just think of it like I have this bootstrap. How do I make sure as I tie things together, everything's encrypted between the cluster, and you do it in a very secure, methodical way. But the one I've been spending the most time on is this thing called confidential containers, which is, in the end, you want security. You want to have that finest granularity around the work that you do. You want to make sure it's only that container which is kind of executing, the pod in this case, not just the container that's been within the TEE. So because of what we do, and because of how the hardware is implemented, it's implemented as extension to VMs. So we use Kata to encapsulate that container in a VM. And once you have the VM encapsulated in a container, well, off you go. It has that kind of security profile where you can't get not just, the usual of east, west, and north, south, but from that hypervisor, you can't get into it at all. So that's kind of like where, what we want to do is really to have that protection in there.
And TE, that's trusted execution environment, right?
Trusted execution environment is like the industry standard term. When you go to Intel, they call it Intel TDX is the thing which is, an AMD Seb SMP. Everyone seems to have done an alphabet soup of acronyms. I think ARM is called C. So they've all got different technologies. The exciting one at the moment, as well as NVIDIA, are supporting it for their H100 and better GPUs. So when you say I want to share a GPU, so with NVIDIA and MIG GPUs, you can actually grab the GPU, grab 1/7 of the GPU and have guaranteed isolation between the different GPUs. So that means that not only are you encrypting within the CPU, but every time you go across the wires between the CPU and the GPU, you've got that isolation as well, which is really cool. Now, the one thing that, just to explain that what we do there's kind of two topologies that we do this. So one is on bare metal. That's just like on the cusp of becoming GA. I've been working with the engineering teams doing some testing of their tech preview code base. We've got some partners and clients who are already deploying this for real production core banking applications, which is awesome to see. Like protecting that they're using it to protect cryptocurrency cold vaults. So the one thing you don't want is a state actor kind of coming in and rifling through your cryptocurrency cold vaults. That I think is a real good use case for this kind of technology when you want to put that extra security premium on top. For public clouds, because we can't do nested virtualization with this because it's a hardware feature we need to get. We do these things called peer pods. We ask the public cloud provider for a confidential VM. So you go on to, say, Azure. This is where we've been doing this the most. You say confidential VM, and there's a whole series of confidential VMs that you can choose from. So like I'll spin up a pod inside a 2 gigabyte, is a 2-core 4 gigabyte VM, and have just that pod in there. So it gives you this really good sandboxing. From an OpenShift perspective, you don't actually see the extra node; it just gets dynamically spun up in the background, which is nice. You don't manage it; OpenShift manages it for you. If you delete the pod, all the VM goes. It's all ephemeral. Which is really awesome.
Oh, that's nice.
Yeah. It does mean that, the only downside to this is it's yet another type of instance you need to consider on Azure. And because it's CPU feature bound, it's not available everywhere. So when you're kind of spinning it up, sometimes it's like I can do this in Korea Central and I have to change it to this for East, for Singapore, and this for US East, because the instance availability changes everywhere. Now the actual problem that we have, though, of course, is you actually have to prove this because security tool, like everyone sells security tools, and the only way that this makes sense is if you can demonstrate the encrypted workloads are there all the time, and you can do that without having to go through an audit process. Because you have to go through an audit process, then you're trusting someone who is doing an audit and you're trusting them to do it. And they only do that every 6 months. We want to be able to dynamically say, hey, prove to me that this is encrypted. So when we do this, we go through this process called remote attestations. So we want to basically say, hey, we've encrypted the workload. That's one half. The other one is we want this remote attestation. So what does that really mean for us? So when we think about the software stack that we have in here, you've got some hardware, you've got RCOS, you've got the software, the middleware that you have and the workload in the pod. We want to make sure all of it's good. So we want to make sure if part of it's bad halfway through that we don't release the things you need. So that's usually a secret. So it might be you've encrypted some data in S3 and you want to make sure you can't decrypt it. Could be the API keys to something else. It could be your TLS private key. We want to make sure that if this happens, that you're not going to release the secret to the workload. And that kind of has to be like that, very deterministic in terms of what you're doing. So that kind of works by when you create an application, it creates a TEE and say, I hold something, data in external storage, which is encrypted. Maybe it's a LUX key that I want. What you really need to do is you need to have a mechanism for proving that you trust. So we talked about confidential containers. Confidential containers kind of has two pieces. One of them is sandbox container operator, which does the actual booting of the confidential container. The other one of this thing called the key broker service or trustee. And trustee's job is really simple. Say you've got something like HashiVault as your key management service. Its job is to say, hey, Hashi knows about keys, but it doesn't know about hardware. What it effectively does is it says, hey, when you boot up the application with the TE, rather than going to Vault, you go to trustee and say, hey, give me a key. And trustee says, hey, show me that you're secure. And because of the way the TEs are structured, it gets information which is signed by that private key on the chip. And AMD and Intel and IBM, they all create a certificate based on that private key. So when you say, hey, is this chip secure? AMD or Intel send you back a certificate saying this chip is secure if it has this version of firmware loaded on it, which is the information which gets signed. And you also sign other things like the initialization data for the VM, like you can use it to sign the payload and actually do things like enforce container security. So I know that you were saying that you had the team from the software supply chain people. Like you can check in that init data to say, hey, did we have the same init data, and did the init data rules specify that it has to be signed with a certain key as well? So you can kind of bundle all of that up and say that's my measurement. So that becomes really like a really locked down piece. Now, the good news about that is it increases your security a lot. The bad news about that is it can be a bit of a struggle with some people. When you say the only way you release a secret, it's kind of makes the assumption that all of this stuff on the left-hand side, that has to be somewhere else. There's no point if it's accessible to the same OpenShift admin. You just kind of destroyed that benefit. So that's a kind of trade-off that you get here. Is it does protect you really well, but it increases the complete. All of a sudden, you have a multi-cluster system that you have to kind of introduce into the environment before you have that meaningful demonstration of security. So. For me, when we talk about this, often we talk about, if you're talking about this application service running in the cloud, you're often saying, the key broker service is sitting on-prem, where you trust the infrastructure more because you don't trust the cloud provider. It gets a little trickier on-prem because it's like, who's going to run, if this has been run by the OpenShift team, who's running this infrastructure? Because, usually there's only one OpenShift team in a bank or something like that as well.
So Chris, is T part of Sigstore?
No.
With the Arch has, I think they use a lot of Sigstore, like Cosign and Recore and all that stuff. So is T kind of like part of that whole umbrella, or is it something different?
T is really a hardware feature. So the way I think of it is when you boot up a confidential container, it boots up a shim VM. So Kata, which is the component underneath this, kind of uses QEMU to boot up a shim VM on OpenShift. So when I say shim VM, there isn't an OS disk at all. There's literally an initRD image which gets bootloaded into memory. Like there is nothing in this VM shim, and then it just boots up the pod. So it's as minimal as what you can get. It's absolutely predefined, so it's all signed. So for the TEE perspective, you boot up this shim VM, and then it gets fed init data. So the init data for the VM will have information like it'll have a set of rules in there. So some of the rules are really obvious. Like if I want to protect my pod, the first thing I want to do is have a rule which says, hey, no one can RSH into my pod, because what's the point of protecting the memory if you can RSH in? So that's really important. And the same for reading logs. So I can't read the file system, because if I mounted a secret onto the file system, I'd be stuffed then as well. But one of the ways we do that is for SigStore. When you sign it, you can say, here is an acceptable list of signatures or sign-in keys that you can use. So you can either tie that to the root, like the SigStore. If you use GPG keys, you can assign it to the actual key as well, depending on the approach that you use. So
Okay.
It's more, yeah.
Yeah, so I said T because I was staring at it. I was really talking about trustee, but that actually turned out to be an awesome answer. Yeah, so just so you know, that's what adult ADHD looks like. So you're welcome.
Yeah, no worries. I mean, I think for me, it ends up as being 15 different Claude sessions running at once, trying to do different projects at the same time. Yeah. So what I wanted, so Sully made me feel a little bit guilty, because at the moment I've been building this, and of course my cluster is rebuilding now, so I don't have a demo. So what I thought I'd talk a little bit about is some of the use cases that we've started to see people do, because it's a little bit different to the kind of typical scenarios we have. So
real quick before we jump into that, we did get a question about this, and so just to ask you. So from Dwayne, good to see you again, Dwayne. By the way, he says, hey, the administration has rolled back some cybersecurity in the supply chain. Is that more of a reason for you to use confidential containers?
And
Look, I mean,
here is referring to the government.
Yeah. I mean, so it depends. Like I said in APAC, so it depends. Often is the perspective of, do I trust the hyperscalers? If you're in Singapore, like you have hyperscalers, and they're hyperscalers from China and hyperscalers from the US, and I think people don't trust either of them in some ways. So that's one role. I think it in the end, confidential computing and confidential containers is a security technology. So I use it when there's a demonstrated. It makes sense to use it when there's a demonstrated need, when you're really worried about the data as a starting point. So if I said I want to protect my cryptocurrency cold vault because I'm a bank and I'm trading a couple of 100 million of crypto for end clients, not just the cold vault itself, but that's probably held in an HSM, but the data path to the cold vault all of a sudden becomes critical, because anyone can do bit flips in that data path. You're stuffed. Like someone can change the address of an outgoing Bitcoin transaction, and all of a sudden that money's gone. So I think for me, it's really just like, it's a security technology. You use it where you want, and that's where I wanted to walk through some of the scenarios in terms of what you do. I think for the administration itself, look, that's a business risk decision often for our clients. That really comes down, and you kind of see that percolating in different regions where craziness in the world, and I won't pin it on any individual government, is kind of increasing people's focus on security. I think that's a fair assessment, irrespective of any one individual person in a government.
Got it. Yeah, because this part is more about the data in transit, not so much at rest or even in use. It's more like the in transit use, right? Or I'm sorry, I said that backwards. It's the data in use, not the data in transit or at rest, right? It's like the actual stuff that you've got your hands on at the moment.
Yeah, absolutely. But the other one for this is, like, in the end, it kind of builds on a set of security technologies. So if you think about TSSC, like I kind of really need to, if I'm going to be really careful about making sure my hardware is really secure, and that the hypervisor is really secure. If you go and bomb in some random code from GitHub that you scanned and didn't check, then there's no point.
Yeah.
Like you're making you've closed one door, but you've opened like an aircraft hangar wide doors to make it easier for someone else to kind of get to your supply chain. So I think if you're not thinking about like the software supply chain integrity first, it's probably not really the technology for you. You probably want to be thinking about those kind of technologies and building up to COCO when you kind of use that as a really secure encapsulation technique.
So
Gotcha.
just to clarify or maybe reiterate there, like the difference between confidential containers is protecting the platform from the app by giving it more or better thorough encapsulation.
No, I would say Cicada, which was like putting shim VMs under just like normal plain old VMs, was protecting the platform from the app. This is protecting the app from the platform. And okay, I can see a question. If running as a managed service provider with multiple tenants, how do tenants verify the workloads are encrypted? So the answer to that is yes, you can provide your own attestation. So when you're using Azure, you're already kind of providing your own attestation. But if I'm running multiple users, even in an enterprise, you can run your own attestation server for each individual namespace if you wanted to. You can actually override it on a per pod basis. That you can do that kind of configuration. So there's checks and balances you have to kind of articulate. Like, do you want to let people do that override or not? But you definitely need to do that based on the scope of the secrets and the scope of the trust is the scope of your attestation server. Okay, let me just kind of jump in and I'll kind of talk about some of the use cases that we've seen. I kind of divide it into these kind of these are the sensible use cases we see people doing, like in-platform segregation. This is primarily on-prem when you have multiple people and multiple namespaces and they have tight security concerns. There's reasons why people build big OpenShift clusters and don't want to build like tiny OpenShift clusters, and they want to segregate out workloads when they're trying to do scale and efficiency and allow bursting. Using it for multi-level security environments as well. Especially if you have precious expensive high-end B300 GPUs, you might want to think about how you manage the workflows for that. The other one is the physical asset compromise. So you are encrypting data in memory, you are measuring from hardware, you start to get additional questions around what happens if someone can steal your stuff. And I think I talked quite a bit about the high value asset compromise. So the scenario I was talking about, like that cryptocurrency scenario, that's not something I invented. That's real. We've got clients who are actually doing that today in production with, they won't tell me how much money. So that tells you it's a lot. That they've got a huge application. We're protecting 4 pods. Like it's quite a small part, which they think is a business critical part where they spend the huge amount of effort. The rest of the stuff is just standard OpenShift containers running inside their platform. So that's kind of some of the pieces we've been doing. So, just to kind of dive a little bit more into these, one of the ones that has been really apparent is, what do I want to do when I want to deal with multiple security levels, whether it's a government style environment or whether it's just things like, core banking data where you have like transaction data, which is incredibly PII sensitive, is often you end up with all this data in an enclave. You can't do anything with it. You have no compute capacity. They want to shove it down to a lower side environment. It's not going to go from like, a 3-letter agency to the public internet, but it might go into the more general purpose compute infrastructure inside of an enterprise where they can manage it because it's encrypted. Like this one, because it allows you a bigger compute pool and stops you kind of building, it stops individual teams buying hardware. And while I would love to have my hands on some more hardware for my own lab, generally the CIOs don't like you doing that. So it's a good use case in terms of that consolidation. Allows you to get a few more workloads in the same place. Because you can use the confidential computing to enforce the security boundaries outside the platform, means that they can increase that density. The other one which we see a lot of today is, we know that for a lot of at least in a lot of geos, a lot of people have moved their low security workloads onto the hyperscaler. All their development stuff is already on the hyperscalers. What they really want to do now is get some of those high security workloads onto the cloud. So I mean, confidential for doing that that's kind of that obvious cloud bursting one. I mean, with AI and the fact that it's still really hard for enterprises to get AI in that environment. Being able to put those AI models in the cloud, that's a big win. And I was going to say the NVIDIA GPU work is something that we've previewed. I know the engineering team are working on really hard, so that's a bit of a watch this space. There should be some announcements soon, I hope. But that's definitely something that we're really excited about as well. Is being able to move that workload out into the cloud. And I mean the trick here is actually the trick here, which is a little bit is how do I do the network as well? You have to start thinking about that full network environment that I want to do. So how do I get VPNs between all the pods? Is MTLS enough? When you start to say MTLS is not enough when it's super secure, then you get yourself into becomes a little bit more hard, because you have to say, what of the cloud do I trust? At some point, you just give up and start buying hardware on-prem. The one that really is most interesting for me is really the decreased platform team trust. Like, as much as we'd like to ask an OpenShift expert or an OpenShift admin, the bank CIO or CISO really doesn't want to trust you at all. They'd prefer if you didn't have cluster admin rights and didn't log in as debug. So being able to demonstrate that in fine-grained postures is one of the cool things that we're seeing in terms of being able to isolate all the workloads east-west really, really firmly. So I think about that when you combine that with some of the other networking techniques as well. So, I give each of the workloads a UDN and peer it out directly. So they've all got their own network paths out of OpenShift. Then, teams can run just enough infrastructure to run the trustee attestation service. The other thing that we haven't talked about is trustee is boot time attestation, so you can turn it on and off. That boot time attestation means that you can do some really interesting things, like you can have a cold start trustee and then run the other trustee in a TEE on the cluster. So you can kind of become you can have a bit of a how many you can keep on going down. So you can do for clouds it might be okay, I'm going to boot up a trustee in each region and then I'll anchor inside a confidential container and then anchor it back on prem. So you can do a few tricks for that as well. Now I see a couple of questions, so I might just I'll do this one and I'll jump into some of the questions as well. But the other one, of course, is everyone wants to protect their edge device. Edge devices might be flying around. They might be CCTV cameras. They might be 5G radio access networks. All of those are things which people are worried about being compromised because they're out at sites where they can't inspect them, or they fly into the ground and they want to make sure that the memory, like things on it, don't get ripped off of it. Particularly, more than anything else, they don't want the network connection carried back to the infrastructure to be compromised. So, being able to prove that everything is okay before you issue a key to allow network access is a use case that we're kind of, I think people are really interested in as well. So that was kind of like my top level in terms of what's been going on. And then maybe we can answer some of the questions, and I can talk about the validated pattern a little bit if we have time.
Yeah.
Yeah.
So you answered the one about the managed service. So then the next one was, he was giving an example. So he's a user who's connecting to a Red Hat COCO bare metal deployment, which is used by their competitors. What's that workflow look like for accessing that VM?
So you're saying what would the workflow be for
I think for verifying attestation.
Okay.
Verifying
yeah. Yes. So inside each of the VMs, and we actually have an RPM installer for RHEL coming as well, is a thing called trustee guest agents. And trustee guest agents is the piece which exercises against the extended APIs that you get inside the TEE to kind of say, hey, here's the evidence that I want. So what you do is it exposes a 127 URL is the simplest way of getting secrets. So you basically say, hey, to trustee guest agent, it's like, please get me key number 1 or key A, and it's actually sometimes it's OpenShift secret A on the other cluster with key B, and it will go and that will start executing the flow. So when you do that, it goes to the KBS and says, hey, go, which you've configured, the KBS is configured in. So trustee data is configured in at initialization time. So either you provide that when you boot up the VM, or the platform provides that as a default. So you go and connect to the KBS and you say, hey, I want this key. And the KBS basically issues a challenge to the underlying shim VM. So that process of the challenge response is automated. The configuration effort to kind of manage that is all about collecting the reference data, because obviously you can, there's a set of stuff which you can collect, which is simple. So I can collect my initialization data. You can also collect facts about the underlying hardware and put those in as reference values. So you can literally say, I want to pin it to an individual server. So that workflow kind of works. The other one for OpenShift in terms of the application space is there is a version of sealed secrets for trustee. So unlike the sealed secrets, which have a bundling encryption, the sealed secret is actually just a reference. So it says, hey, go and point at trustee and get a secret for me. And that completely hides the workflow from the application side. So you get the, so to kind of ask the question of how do I kind of access it? So if you've got an application there, well, yeah, you make that decision about what the application exposes. You can turn it to debug mode if you need to get RSH access in OpenShift or not. But once you kind of lift the security envelope up, it becomes the APIs that you've exposed from the application are the ones that are there. Then the question is, how do I get the secret in there? And the secret is actually issued by going and talking to the trustee endpoint and saying, hey, give me the secret. And there are a couple of ways of doing that, but you kind of automate in your application. The kind of the cheap hack way of doing that is you use a net container and use curl against that like the 127.0.0.1 endpoint. Like that's like the kind of hacky one. Like when you really don't want to do that, but it does mean you don't have to change your application code. You just kind of curl it and then get the file mounted into the location that's expected in the main application. So the other one is a curveball, but when become GC, I'm not sure I know the answer for that one. Sully, have you run into that one before around boot image management?
I don't know the answer to that one. And RHOP 9, I don't know if that's related specifically to confidential containers or more broadly with OpenShift and RCOS.
Yeah, I'd have to have a look at what our roadmap is for confidential computing and vSphere. I mean, there was some support for RHEL inside of there were some confidential features inside of vSphere, but I haven't been tracing it as much as our self-hosted use case or the public cloud. Like on-prem, the density wise, it makes way more sense for OpenShift to be running on bare metal if you want to run lots of confidential containers. I haven't been looking at vSphere. The other one is, yeah, no worries. If a firmware flaw is discovered, how is the attestation revoked? Okay, that's a really good question. So if the firmware flaw happens, the attestation effectively is, there's two phases of attestation logic that happen. So the first phase of attestation is actually a relay which goes from trustee to AMD or Intel. It can be cached. Caching obviously increases latency and risk. Where you basically say, for this chip serial number, return for me the certificate which corresponds to the chip, and in that certificate is the acceptable versions of firmware. So if you think about what happens if you have a set of infrastructure that you run, if you don't update the firmware and you keep on provisioning containers, what's going to happen is that you're going to get to a point where the container, like you're going to get a certificate back and it's going to say, hey, AMD's updated the firmware. They had to do that in the last 6 months, just so we're clear. It does actually happen. This isn't a crazy question. Then you should be on a later version of firmware and it'll reject it because you haven't updated the firmware. So that's like that first level revocation. The other one is if you're really paranoid, you basically collect extra information about every system you have, and you put that in a register as well. That helps you know that whether you have drifted, but it doesn't help you against that update. So the update really is that certificate mechanism as opposed to the reference data which you collect. So what exactly is measured by the hardware? So because of the way that the confidential virtual, and this is where I will stretch the limits of my knowledge of exactly what is measured for every individual scenario. So when you do, the first thing to remember is you are reliant on the chip vendors. In some scenarios, a VTPM is used. The VTPM has to be open sourced for this to make sense. So SVSM is being introduced into some of our components. It's not actually mandatory to have a VTPM in here because we don't store state in it. You can directly boot the initialization. But in Azure, some VTPMs are used in their infrastructure. So that is closed source. So there is a risk associated with the fact that you are on Azure compared with, say, doing this on-prem. What people are really relying on in some ways is the fact that Azure are using the same firmware for Intel as everyone else. So you can kind of measure the security of the Intel firmware independently. That's like the kind of cross-verification that is there. So in terms of measurements, you get a measurement of the firmware or various parts of the firmware, including the physical TPM. For the VM, you basically get a measurement of the integrity of the file system. So we use FS Verity on the FS Verity, DM Verity, on the VM image itself. So you know that the VM image hasn't been tampered with when it boots. You measure the initialization data. So think about the CloudNet data that you have there inside of that, and that includes your configuration payload. And I'd have to think about what else you can get a few measurements out of the VTPM as well. It's using the PCR data which you have inside of the TPM is a primary mechanism of measurement, but it's measuring the VM because you're basically skipping over the hypervisor itself. I can probably get some links we can find for in the future as well. Cool. I guess if there's no other questions, I might do a little plug, which is the primary mechanism which I've been doing this is the other one I was going to say is obviously it makes a lot of sense to do a hub spoke deployment. So you put the KBS and your KMS and your reference values on a trusted infrastructure. It seems like there's a spoke, and because you have evidence flowing one way and want configuration to flow the other way, it's pretty clear that it makes sense to use ACM in this infrastructure as well to do some of the management. So to kind of jump on one of Jonny's things as well, one of what we've been doing is, or I've been spending my time on upstream, has been testing this with the validated pattern. That the one thing I probably skipped over here, where people might have realized, is there is a lot of configuration to do to get this, kind of singing together. There's a few certificates kind of kicking back and forth in here as well. So we've kind of been using this as a demonstration, a way of testing all the infrastructure. We've got it up to the GA releases, which run on Azure. Azure is a platform where we are GA on. I'm at and I'm in the process of kind of testing the bare metal pieces. So I just want to kind of throw that out there. If you want to give it a test, it's a good way of doing it. On Azure, you should be able to bootstrap yourself up pretty quickly. It takes a couple of hours because deploying it needs you to do reboots of all the nodes, which of course increases time to deploy. But it's pretty stable now, which is great. We've got some secure by default infrastructure. I would say 6 months ago, we did some initial testing and we found out some really ugly things, in the corners, like, oh yeah, can't use private certificates. Every enterprise uses their own CA chain inside. Most of those things have kind of flushed out now as we go to GA with bare metal, which is really awesome as well. So, yeah. Anything from yourself, Jonny? Or
No, I think that's awesome. Great plug.
Yeah.
So I do have a question though, so with data sovereignty and sovereign cloud and all those things, right? Like these big buzzword things, like confidential containers is really like that core. It's really at like the base layer, right? So you have like the hardware encryption, and then you start working your way up, and then you start locking things down like through like a zero trust, and then like just like the further you go in the stack, like the more like you're using like a zero trust type of thing on top of that, right? So is that where you see COCO kind of fitting in? Is that base layer, or do you see it more like in the zero trust kind of paradigm?
I think it kind of sits in the zero trust because you're kind of isolating people from the the infrastructure admins. So I mean, when you think about sovereign, one way of it is I'm really worried about some hyperscaler, some service provider accessing that data. So I want to protect myself from them. That's an obvious one. So it's a sovereignty without having to buy infrastructure, which is a nice thing to do if you want to protect your data in the public cloud. So that kind of appeals to a lot of people. When we talk about the kind of more sovereign service providers, I mean, like it or not, the hyperscalers have spent an incredible amount of money building all of these sophisticated controls. They need to bootstrap up for some of their critical infrastructure. So this helps them, get to some of the security postures that they want, where they don't have the luxury of building custom silicon like an Amazon or Google or Azure or Alibaba do. I mean, it's just something that most people can't do. So I think this is like the standardization of some of the things that they're doing there, and have been doing for a long time. I mean, they haven't been doing confidential, but that the hardware anchored security is a really cool way of doing it, getting a lot of security without having to, especially if everyone is shipping it now. I think that's the other big change is up until about last year, you kind of had to specially order this. Now, like almost every AMD chip that's still GA, which is any Epic has it. Intel, all the current generation chips have them now, have Intel TDX now as well. The ARM, I think we're looking at later this year. So as an example, Vera Rubin, like the new NVIDIA stuff, is meant to have it. So it's kind of going to be like the hardware support is all of a sudden going to be ubiquitous. So I think it's going to be something people are starting to really use as opposed to something you really have to hunt to use, which is the previous state.
No, that's awesome. Hey man, I appreciate it. And we're creeping up on the top of the hour here, so I want to make sure that we are respectful of your time because I know you got to bounce. But is there any last thing you want to say? Like anything that you're working on, anything that's coming up that you want to talk about really quick that we can use to kind of kick off the end?
I mean, I think for this one, I think it's really just getting us like GA and bare metal, like working with the engineering team to kind of get that stuff kind of kicked out. The other one is that one of the areas we're starting to think about is how do I bootstrap this up? All of a sudden, you have to have a trusted cluster. So how do I do that cold start? That's been a little bit of a problem. Like if it's the cloud, it's okay because you've got on-prem, but we're also looking how we make this cold start so you can kind of do everything confidential. So that's going to be like the cool thing, kind of coming up on this as well.
Nice. Awesome. Well, dude, I learned a ton today. I mean, I really did. I came into it like kind of blind, but at the same time, I was like, I feel like I have like the concept down, but I honestly didn't know jack. Like, so I mean, I've learned a ton. So I appreciate you coming on.
No worries.
Hey, so this is one of those areas where I think like, oh yeah, like you, Jonny, like, oh yeah, I kind of have a grasp of things. No. I know basically nothing about this.
Yeah.
It's fascinating. And it reminds me of like why we have, so one of the questions that we're getting ready to answer is about like the skills that you need. Like it's so varied. It's so like different specializations, different focal points. Finding somebody who's a subject matter expert, it makes me feel just completely knowledgeable on these topics that you're such an expert on, Chris. So thank you.
Thanks guys.
So Chris does have to bounce. So we'll let Chris bounce, and if we want to answer the question directly, and then we can start to roll out. But yeah, Chris, thank you very much for coming on, man. Really do appreciate your time.
Yeah, thanks a lot, guys. Thanks for having me. Okay, talk soon.
Yep, see ya.
Bye.
Cool. And yeah, the question, did you already answer the question, or do we want to answer it about the skills? I feel like we probably already.
We can talk about it a little more in depth if you'd like. But my thing with that is Red Hat is a big company, and there's, every role that you can imagine exists inside of the company. From finance to HR to all of the sort of back office roles. And then if you think of like even within the product, right, an account team has different folks. The account executive, who's more of your pure salesperson. You have SA or solutions architects, which are technical folks, but they're typically broadly knowledgeable across the entire Red Hat portfolio. You have SSAs who are more narrowly focused and technical. You have TAMs, technical account managers, who are like focused entirely on like helping with support issues and stuff like that. You have services, consulting folks, you have learning folks. On the product side, you've got what Red Hat, we generically refer to as the business unit. Which comprises of 3 primary roles. So tech marketing, which is my role, product marketing, and product management. Each one of those has very different skills associated with it. Jonny, you're in engineering, and there's an almost infinite number of permutations of skills there. So it's one of those, like, it just depends on the role that you're looking at. And, I'll focus on tech marketing for a moment. Like when I interview junior folks, I really, all I'm expecting from them is I want them to want to learn about the technology and the things that we do. Like if you're just out of college, I don't expect you to know the depths and ins and outs of different OpenShift things. And then as folks increase in seniority with tech marketing, typically what happens is we get more narrowly focused. So you go from that's sort of true and sort of not true. Like as somebody that new out of college, like I'm going to give you one feature and basically say go learn everything you can about that feature. And then as you move up, it becomes now you're learning more about these 6 or 8 features that comprise a capability. And then you become responsible for that capability. You're the subject matter expert for that capability, and translates into the technical value and business value associated with it. And then tech marketing is weird because you hit an inflection point, and then suddenly it's now you're responsible for that capability, but across all different areas. Like I'll pick on virtualization. Like how is virtualization affected and influenced by like confidential containers? Is it? Maybe it's not, and then we don't have anything to do there, but maybe it is. Like, hey, can I run OpenShift virtualization VMs in confidential containers? Pretty sure the answer there is no, because it would be a VM and a VM. But like thinking of stuff like that. Whereas on the engineering side, right, as you go up and you become more senior engineer, like you almost, I think there's a similar inflection point where you almost stop writing as much code, I think, and then you become more like architectural and like helping guide the way that the features capabilities are implemented at that level. So I don't know, I'm kind of rambling of basically saying like, what position are you interested in? And then you kind of go from there and look at it. All of the roles that we post on jobs.redhat.com, they all have like a description of the expectations and stuff like that. And you can, I think we try and use industry standard things, so you can compare it across different companies as well.
Yeah, and don't get lost in the job description. Like if it says that you have to have Python and Go and Ansible and OpenShift and Kubernetes and RHEL and whatever, you don't have to have every single one of those things, right? But just be honest with yourself. Don't, if it says, hey, if it's looking for a Golang expert and you're not, it's probably not the right job. You know what I mean? Like let's just be realistic. But like I think when you're interviewing as well, like just be honest. If you don't know, you don't know, and it's okay to say I don't know. Don't dig yourself a hole, because so I'm sure you've seen it too, where you interview somebody and you ask them a question and it's not meant to stump the chump or anything like that. It's really just to see like how you think about things, how you think through things. Are you willing to just say, you know what, I don't know off the top of my head, but I'll go look it up, or this is what I would do. I'd do, read a man page or whatever,
That's the key part. Like years ago when I would do technical interviews for folks, like when I was an administrator and an architect, as a customer, you're interviewing folks for like, junior, senior, administrator type levels. And my goal was basically to find the most crazy, esoteric, unknown things and ask about that. Because I don't care if you know it. The point is, like, nobody knows everything. Nobody can possibly know everything. What I want to know is, one, are you willing to say, I don't know? And most importantly, but I think this is how I would find the answer. Right? I think it's related to this. So I'd start by doing a man on this, and then hopefully that'll lead me to some information where I can go and look at this, and then I can trace back, and then I think it'll probably land me over here, type of thing. Like, by far, that's the most important part. And similar, like, working on the OpenShift product side, there's 80 product managers, each one covering an average of like 4 or 5 different features inside of there. So you think of OpenShift and all of the different capabilities, like there is, I don't know how many things that are happening at any given point in time. Jonny, I've shared with you the whole company readiness document, right?
Yeah.
The stuff that we put, that the product management team publishes and they talk about on the live streams, the What's New live streams, is like 20% of the change that happens in every single release. And so you very much have to accept and realize, like, there's no way you can know everything. Like this thing that our Hope 9 is asking about, I didn't know about that. I'm trying to do some research and I'm asking questions in the background of does anybody know roadmap on this? So you very much have to be like flexible and be willing to do those things. Anyways.
Yeah, it took me a while. I think, like, I don't know. I've always been pretty honest with myself. I feel like it's, dude, I don't know. But like to be confident and say I don't know, I think it took me a while to get there, because I always thought that I had to have an answer. But then after a while, I just realized, like, it's actually best just to say no, or I don't know, and then just leave it at that. And then if there's any follow on, then they'll ask. And if you don't know, you just don't know. I mean, like, there's no harm in it.
Yeah, I'll tell you, when I first moved over to the vendor side, it was hard for me to like realize, or it wasn't hard. It took me a minute to realize, like, saying I don't know is super important. Because if I make an assumption and I say, oh, it's this, and I'm wrong, like, typically folks will take what we say as a vendor, like, as Red Hat folks, like, folks take it as law, as gospel, and if it's wrong, then they get upset with us. And so it can be really important, on the product side, on the vendor side, to be able to say, like, no, I don't know, but let's figure this out. Let's find the right person. Let's get the right answer. Say something about OpenShift Lightspeed. Lightspeed is amazing. I like Lightspeed. It's an LLM, with some RAG, augmentation in order to help you find the right answers. My perspective, as I use LLMs, Claude and ChatGPT and Gemini and all of these things more and more, not just in work, but in everyday life, you still have to be careful with them. What was the thing recently? I saw an article about how, like, AWS's internal code assistant declared the human written code to be garbage and just deleted it, and it caused like a day or a half a day outage. Like, you still have to be super careful with those things. So Lightspeed, like all of the LLMs, it's a tool to accelerate. It's not a replacement. And I think whenever I talk about it, I hope whenever I talk about it, I make a point of saying, like, hey, like, Lightspeed isn't going to put anybody out of a job. But hopefully what it can do is, when you find an error, when a pod is crash looping, when this thing isn't doing it right, when you don't remember all of the different things you need when creating a new route, instead of having to go and search the documentation and find the right collection of things, instead you can go, hey, Lightspeed, help me with this. And because we have some existing knowledge, we've probably done this 1 or 3 or 5 times, I can look at it and say, yeah, that's probably right. Let me do that. Or let me take the example that I gave here. Hopefully, if it's your first time, then you're going to look at it, take it with a grain of salt, and ask it for, like, can you give me the documentation links for that?
Explain what you do.
And that's one of the things that I've gotten into a habit of asking the LLMs. I'll have a conversation with it about, like, tell me about this feature, or tell me about this thing. What does this mean? And then I try and ask it, like, what am I missing? Or, like, is there something else I should be asking about? And then they'll try and give me an answer for that. And, hey, you're missing this concept, or I'll verify my understanding with it. So again, it's a tool. It's not a replacement.
Yeah. What I've been doing lately is I'll write something, and then I'll pass it through, like, Cursor or something like that, right? Or Claude. And I'll be like, hey, is this optimized? And then it'll come back about, yeah, that's awesome, or that's the worst thing I've ever seen. And it'll give me some suggestions and stuff like that, and then I'll start messing with it. It's just, for me, it's cool because it's like, all right, it's this like, it's like our Hope 9 is saying here with the dry run. It's a syntax check on it, right? Or it's a sanity check on, like, is there a better way that I could be doing this? Because right now, here's how I understand that this flow works, and here's how I think it should go. But is there a better way? And yeah, I mean, that's sometimes it's come back like, no, this is good to go, and then sometimes it's been like, yeah, here you could parameterize this, and it's been pretty cool.
Yeah. So yeah, it's. Anyways, back to the original. The roles are myriad. The skills are myriad. There is no one set of skills that will always make you successful. If anybody's familiar with tech marketing, kind of across the industry, a lot of times tech marketing gets associated with evangelism, right? We go out and we present at conferences and stuff like that. That doesn't mean in order to be a successful tech marketer, you have to be comfortable with doing public presentation, public speaking, because my extended team is 30-ish people. Right, we have peers in the RHEL business unit. We have peers in the AI BU, in Ansible, so on and so forth. Maybe 20% of us do public speaking. Right, going on a live stream or creating YouTube videos, and being able to edit videos. Like all of these are different skills, and it becomes what are you good at? What are you passionate about? What are the things that you enjoy? And then you fit the role and the job requirements against those things.
Mm-hmm.
I don't know if Red Hat's is super unique in that way or not. Because what I've found is, like, with my team and both my direct team as well as my extended team, like sometimes when we were in the military, Johnny, you remember, right? Needs of the Navy, right?
Yes.
Where that always takes precedence. Like, oh, you don't want to go to the USS Never Dock, the first thing that's gray and floating. I'm sorry, the needs of the Navy say that you go there anyways, right? Instead, Red Hat in particular, and I know other companies are also like this, but Red Hat in particular is very much like, hey, like, we need somebody to cover this broad area. But how that gets covered, what are the things that you bring to that role, right, is often very unique to the person, and like we try and align it to that person's skills and preferences, and every one of the semi-annual, right, the every 6 months performance review stuff that we do, right, there's a question that is, what are the things that bring you joy and energize you, and what are the things that take away your energy? And it's a conversation that we have.
Yeah,
it's a conversation that you have with your manager every 6 months. So yeah, the fluffy HR questions that they're not meant to be a direct thing. They're meant to be a conversation starter. Dealing with Johnny and the live stream is just, it's awful. It's the worst part of my week. I really need to get away from this. And then your manager.
I completely understand.
Yeah, yeah, thanks for posting the link, Johnny. Yeah. There was a couple other questions that had come up. Yeah, how many flags for LS can you list? It's LS is one of those that's safe. You can just go with all of the letters of the alphabet, just lower and uppercase, and you're probably gonna. Yeah,
that's like curl. Curl's like that too. It's just got like a whole, like, it's even got like a sub menu, like where you can go in. It's crazy.
I had a crazy, like, one of the memorable interview questions that stands out to me when I was interviewing to work at Oracle as a consultant was like, how would you handle if somebody replaced the CP command on the system? So basically you did a CP LSCP. So you copied the LS command over top of the CP command and named it CP. So that anytime you ran the CP command, you were actually running LS. So like, how do you replace that binary without the CP command? And there's a bunch of different ways you could do it. So just ways that they try and get you to think out of the box and think through things.
Yeah, my favorite one, where it was like, because you have the pressure of the interview, so you're nervous, nothing, you're not thinking straight anyways. And Taylor Biggs actually asked me, he was like, how many 3-letter commands can you give? And then basically just sitting there. And it's, like, it's easy when you think about it right now, right? Because you're like, oh, okay, it's awk, get, whatever, And he was just like, that it? That's all you can do? It's it was good. It was good. I miss those days.
Yep. Like I said, I'm a manager now. My hands-on keyboard time is, if I'm lucky in a given week, it's like 15%.
Yeah.
It's just, I spend a lot of time doing other things, and I do miss the technical hands-on keyboard aspect. It's something that I enjoy. I do a little bit more of it in my spare time now, like my after hours time. So,
Mhm.
for example, this morning I learned that my cat stepped on the power button for the home server, and, and so at 7:25 this morning, and so at I don't know, like 8:45, I'm like, why is none of this stuff responding? Like, what's going on? And then I spend a few minutes like, what has happened and all this, and then I finally go upstairs to where it's at. I'm like, why is it powered off?
Cat's putting the cigarette out. Like, it was me.
So yeah, we figured out that the cat had jumped up there because we've seen him up there before. He had jumped up there and his paw hit the power button. So yeah, working on different stuff. I spend more time after hours. And my
Damn
wife,
cats.
I know, right? But yeah, my wife and I, she's very patient of like, well, while she's watching, because she likes murder shows.
Mhm.
Right. So while she's watching murder shows, I'm banging away on the laptop.
Hell yeah.
you
That's
know,
that's our dynamic too. Like I'll sit out here with my daughter and my wife at night, and we'll watch. They'll have a show on, and I'll just be banging away on my laptop doing stuff. I'm just trying to catch up, because like I do try during the day to focus on like nerd stuff and just like go hard during the day. Otherwise, man, you know how it is. Mind starts wandering. Next thing you know, I'm painting the wall, or pictures are getting straightened up. It's just
see,
if I don't keep it under control, I'm a mess.
yeah, see, my rule is I don't do work stuff after hours unless it's like manager things. Like if one of my people reaches out to
Mm,
me, because like, and Slack now has the priority
yeah.
folks, so like if one of them reaches out to me, like absolutely,
Hmm.
I'm always available to them, but I very rarely answer email after hours, unless it's a day where like I had to take an hour to go to a doctor's appointment or to pick up a kid
Yeah.
or something like that, and then I'll catch up on things if I need to. But
Yeah.
yeah, usually it's after hours. It's all hobby stuff for me. What's going on in the home lab. Self-hosting things. That type of stuff.
I should start doing that again. I haven't done that in a while. But I've been here and it's just been, it's kind of nice to be honest. Like, cause I'm 5 hours ahead of East Coast. So I literally have like this 5 hour block where it's just quiet until the East Coast gets going. And then, so my day will roll into the afternoons pretty late sometimes. Like I have an 8 o'clock call tonight, but other than that, like it's once I hit about 5:30, 6 o'clock, it's pretty quiet. So,
Yeah.
but I've been trying to take advantage of the quiet. I've been trying to just like lock in, and I'm like, all right, I'll leave write little goals. Like, all right, here's my nerd goals today, and then just lock in. So that way, because I'm a freaking disaster, dude. Like I'm all over the place.
Yeah. Yeah. I know how that is. I have to be disciplined about it as well.
Yeah.
Um, Circling back on topic, RHOPE 9, I don't have an answer to your question about the boot image management stuff. The research that I've done on the things that pop up I think it's related to AWS and Azure, mostly because that's also where we have managed services, ROSA and ARO. So I think it's probably easier there, but that's just a guess. That's just a suspicion. So I'll say I missed that because typically anything that's related to AWS and Azure, I don't pay a lot of attention to. Most of my world is virtualization these days. And while we do offer virtualization there, it's not it's not significantly different enough because you're using bare metal instances from on-prem that I typically pay attention. So I'll see what I can find out there. We'll ask some questions and see what folks have to say. On a tangential note, I don't know if we talked about it here or not, but VCF 9 is supported with OpenShift now. So if you have VCF 9 you've upgraded to VCF 9, you can deploy clusters there. I don't think you can migrate clusters yet. It has to be a new cluster.
Mm.
Yeah. It needs chaos monkeys when you have cure kittens. Yep. They sure are cute though, and they're friendly when they want to be.
Yeah. Cats, man, they're just such a unique personality. Like each one of them has its own thing, and yeah, it's just funny. I have a Rottweiler, and she's stubborn as hell. And I imagine that's probably what happened to cat. I was like, she's not quite as smart as a cat, but she's pretty dang smart. You know what I mean? And it's like, dude, just the sass that you get from cats, it's just it just cracks me up. So
all the critters,
Yeah.
critters. You know, we have 2 dogs and 2 cats, and the 2 cats are very opposite. One of them is very cautious, so like he's not skittish, but like he won't take risk. The other one is just all out all the time.
Hell
And
yeah.
so we typically refer to him as the crash test dummy, because he's the one, like, you know, a bag is open, he'll stick his head in the bag without even, you know, just see what happens, or he'll be the first one to jump onto the thing, and the other one watches and like, oh yeah, he lived, so maybe I'll try it.
That's safe enough.
Yeah. Do we miss any questions, Johnny?
I don't think so. I think we covered them all, and then some. So
yeah, and I know, so usually we have the spiel about, you know, reach out, you know, if you have questions or anything like that. I would say if you have, to the person, I'm looking back through chat to see if I can find your username. To the person who's asking about that, if you have questions about roles, you know, feel free to reach out. You know, Johnny and I are happy to share our experience and stuff like that. You know, and just help however we can, you know, kind of translate things and stuff like that into what it means and how it works. Harry asked about IBM App Connect, and the question was, we have IBM App Connect with 62 cores on a VM, and I want to migrate to OpenShift. How many OpenShift licenses do I need? So my number one rule is I don't work in sales, so I never tell people how much things cost or how much they need. But that being said, the subscription guide is always a good place to go when you want to understand like how subscriptions work and how many you need for different use cases. So let's see, I'm going to share my screen again. So if I go to the subscription guide, and I'll paste this link into the chat here. If you go to the subscription guide, way down at the bottom is examples. And these kind of walk through the different subscription or the different sizing exercises that you need for subscriptions, not cluster sizing, subscription sizing. So it's kind of saying like, oh, my applications consume 1 vCPU and 4 gigabytes of memory. I'm running X number of instances, so I'm expecting to need 250 vCPUs, right? And then kind of what does my compute node look like, blah, blah, blah. Broadly speaking, core-based subscriptions are based, or all subscriptions are based off of compute nodes in the cluster. And then core-based subscriptions depend on if the cluster is virtual, are you using hyperthreading / SMT or not? So the default, we generally default to assuming that you're using hyperthreading or SMT. So it's 4 vCPUs per subscription. So you said 62 cores. So if I have 62 or virtual machines, OpenShift compute nodes totaling 62 cores, I would divide that by 4 and then round up. So that would be 16 subscriptions that you would need to cover those compute nodes. But if you have, so your application is 62 cores, but maybe you expect it to burst up and every once in a while it consumes 72 cores. You would want to have enough subscriptions to cover that as well. If you're not using hyperthreading SMT, then it's just 2 cores, two cores per. There's a bunch of different rules. Like this document is incredibly dense, and it's not a legal document, but it's meant to be a description or more details around the official subscription rules and guidelines and stuff like that. For anybody who's curious, Appendix 1 is the official like subscription thing, but that is a legal document, and legalese is hard. Bare metal nodes, for what it's worth, are different. if bare metal nodes, they recently changed to where sockets and cores no longer apply. So whether you're using, so it used to be, if we go back, I think 2 years, it was a bare metal subscription was 64 cores or 128 threads. So if I had, you know, a 2-socket machine that had, 64 cores, 128 threads, and 1 to 2 sockets. So if I had a 2-socket machine that had 32 cores per socket, then that's 1 subscription. If I had a 2-socket machine that had 64 cores per socket, that's 4 subscriptions. Right? No, 2 subscriptions. Man, math is hard. Never do arithmetic in public.
Yeah, public math is bad.
So if I had 4 sockets, and so if I had 4 sockets, each socket with 16 cores, so that's 64 cores total, but it's 2 subscriptions because it would only cover up to 2 sockets. I think last year we changed that to be up to 128 cores across 1 to 2 sockets. This year it's just a bare metal host. Doesn't matter if you have 1, 2, 4, 8, 64 sockets, and from 16 to 16,000 cores. I know that that's not possible, but it's 1 bare metal subscription now.
Oh, that's cool.
So yeah, that should be reflected in the subscription guide here. I think it's January 23rd. It was updated. So yeah, bare metal. Bare metal also has other things associated with it. So there's 4 editions of OpenShift. So OpenShift Virtualization Engine, which is it's just for running virtual machines. It's kind of akin to like Red Hat virtualization. So when you deploy virtual OpenShift to OpenShift Virtualization Engine, OVE, those virtual OpenShifts need their own core-based subscriptions, just like if you're deploying OpenShift to vSphere or Rev or OpenStack or anywhere else. If you're doing bare metal OKE, OCP, or Platform Plus, then any virtual OpenShift clusters deployed to those bare metal clusters inherit subscriptions of the same type. So if you've got a bunch of OCP clusters that are running in virtual machines, consuming however many core-based subscriptions, if you were to deploy those as OpenShift on OpenShift virtualization bare metal, then they would inherit that. So you can have a conversation with your account team about which one makes more sense for you. Time to watch Hidden Figures. Yeah, that's some math that is well beyond me.
Yeah.
Anyways, I've distracted and/or sidetracked and/or railroaded us into a ditch. At this point. So if anybody has any last-minute questions, please don't hesitate to drop those into chat. We'll do our best to answer those. For anybody who is not watching us live, who has been listening to us for the last hour and a half, please, don't hesitate to reach out. If something occurs to you after the stream and between streams, we're happy to answer questions. Arhopnan, I know you sent us an email. I've got a draft in my inbox that I have not fully finished while Jonny was on PTO that I meant to send out. So for any folks who, any questions occur, you're not watching us live, you're listening to us later on, don't hesitate to reach out. Jonny, JONNY at redhat.com, or Sully, SULLY at redhat.com. We love to get emails from anybody and everybody.
Yeah.
I don't think I've had a chance because I've been distracted and/or sick and brain fog. I ran into a ton of folks at Red Hat One who came up to me and said, hey, thanks, we really appreciate the live stream and everything else. I don't know if I've passed that on to you, Jonny, of all the folks who came up and said like thanks and everything else. We really do enjoy doing this, and we appreciate all the interaction. We appreciate all of the appreciation that you'll show us, especially when we run into folks, out in the field, or when we run into customers. I know there's a number of times where I'll be on a customer call and somebody's like, you look familiar. Like, why do I know you? I'm like, well, it's either because you've seen me on YouTube or corporate marketing abuses my likeness, and you may have seen me in your Instagram feed.
Yeah.
So.
We got one question. It was from DNL 4880. For the new UI enhancements under the node, can we get the fiber channel WWPN, the worldwide part number, or I guess that's part number, I can't remember. But they're wanting that WWPN under the node for that fiber channel.
It's funny you asked about that. So they are working on the new node enhancements for 422. I think Peter Kreutzer came on a month ago or so and showcased some of that. I think one of the mockups has that. The problem is, to my knowledge, that information is not currently surfaced up through an API in OpenShift. So what do I mean by that? Everything that you see in the UI needs to come from somewhere.
Something.
Right?
Mm-hmm.
Something in the API has to be able to surface up that information. Let me give you an example. So let's look at our window again here. So here's my cluster, right? If I come down here to my core platform, so if I come down here to compute, and then I look at my bare metal hosts, right? So if I look at the YAML associated with this, there's various information inside of here, right? It tells me, the CPU, like what type of CPU it is, the megahertz associated with it, how many cores are here, all the different CPU features. Right, as I come down, right, it tells me the network adapters and all of their various, metadata, MAC addresses. So for storage, you'll see I have some information here, and this chassis does not have a fiber channel card. But if that information isn't surfaced up somewhere, so you can see right here is a WWN, so that's probably a SCSI device. So it's a SAS SSD. Anyways, if that information isn't available here, then we can't put it into the UI. And so like one of the things that I had asked the team about is like, if I come in here and I look, like, okay, I don't know why it does this sometimes. Anyways, if I come in here and look at the disks, like I've got all of these disks that are located here. Like, tell me, what does this actually mean? And in particular, like if I look at, let's look at a different node. So like I know if I look at some of these, like this RBD device, I can tell by the size, this is probably a virtual machine disk.
Mm-hmm.
Because when you think about how do PVCs work? Well, when my pod uses a PVC, when it gets scheduled to the node, the CSI driver, basically the control plane or kubelet, will ask the CSI driver to mount the volume and then pass it back into the pod so that way it's able to mount it and use it by the container. So that means the volume has to be mounted on the host, right? Excuse me. And that shows up because this is a Ceph, we're using Ceph inside of this cluster, right? So that shows up on the host. And depending on the permissions of whatever's collecting that information, I can see some of what's happening inside of there, right? Remember, at the host, if you're root, you can see all the things.
Mm-hmm.
So is this in use by a pod? I don't know, maybe. And if it is, like, it would be great for me to be able to see, like, not just, oh, there's a random, Ceph volume that's mounted here, what pod is using it, right? What PVC is it associated with it? What PV is associated with it? So on and so forth. So I can see more information about this. And you can get that information, but it's challenging sometimes.
Yeah.
Because like, if I look at this, there's nothing that links a PVC to a pod, right? If I come here to storage and I go to persistent volume claims and I look at, like the name here tells me that this is associated with a virtual machine. But if I look in here, like, this one does say it's associated with a virtual machine, but like, not all of them have this owner reference associated with it, right? And so what I have to do sometimes, and this also says virtual machine, it doesn't say pod. So if that virtual machine isn't running, or either way, I have to either figure out like, what are the pods running on the node, and of those pods, which ones are using PVCs, and then where are those mounted at on the host? Or in this case, I would have to say, okay, this PVC is used by this virtual machine. What pod is associated with that virtual machine? Now, what PVC is it using, and then where is it running, and where is it mounted at, so on and so forth. So there's no direct way of collecting that information. Right. So if I look at this, this is I'm in that namespace, so that Win11. So if I come up here to virtualization, VMs, and I look at this Win11 demo, you can see it's running. Come on, buddy. It's running on node 7. So like I can kind of work my way down through there, by looking at the pod, right? And then the pod will have, you know, that disk associated with it inside of here. So anyways, long story short, yes, I want that too. We are working in order to get that information in there. I will make sure to pass your comment over to the UX team, so that way they can basically +1 and say, oh, look, somebody else wants this as well, with the engineering folks to help prioritize getting that inside of there. But yeah, effectively the way that all this stuff works is we have to have an API that surfaces up that information. And so long as it's available through an API object, then we can put that into the UI. The UI is, you know, so some platforms do the UI first and then add an API second. OpenShift and Kubernetes are very much the opposite.
Yeah.
The UI is just a visual representation of the API. Anyways, any thoughts, Jonny?
No, I think you crush it. I think it's interesting that we don't have like that one-stop shop for the PVC kind of like lineage, right? Hey, here's my virtual machine, and you know, some graphical. Hey, here's all the things that are associated with it, or all the things that, you know, it's touching.
Yeah, so that's storage is on the list of high-level topics that UX is working through. So networking. Without too much, you know, how's the sausage made? Networking was one of the big ones. Networking and the UI there is actually being handled by the OpenShift virtualization engineering team. The node work, which relies on, among other things, networking and a bunch of other things, is being done by a different group. It's actually the core UI team that's doing that work. And then storage is also on the list, but I don't know whether or not that's where that will fall within the engineering organizations and who takes care of it. Do the volume expander operator work with virtualization? I don't know. I've never tried.
No idea.
Yeah, that might be worth looking into and seeing if we can add it in there. So yeah, I'll poke at that one and see if we can find out some information. Our storage SME, well, one of our storage SMEs for the virtualization side should be online at this time of day, so I'll ask the question. With that, so Jonny, next week's topic is
Conforma.
Conforma.
Yeah.
So jumping back 2 weeks, I think.
Yes.
Yeah, 2 weeks, a continuation of the trusted software supply chain conversation, looking at some of the capabilities that are there. For me, this is top of mind. So I was just in the tower yesterday meeting with some of my peers and counterparts across other parts of the business to talk about application platform things and how trusted software supply chain plays an important role there. So seeing all these things come together is always interesting and always fun. So I'm looking forward to learning more about Conforma and where that fits in with the rest of supply chain stuff. Yeah,
for sure.
Yeah, I know they wanted to talk about it last time, but you know, we ran out of time. We tried to warn them, Jonny. We tried to warn them. However long you think a topic is going to take, it will take twice that long.
Yeah. And then you added nerves, and then like, there's nothing going on. That dude was like he had this presentation, and that was it.
Yep. So we're happy to have him back. I'm looking forward to having them back on. So we also have, I know once we've got a lot of guests lined up over the next few weeks. One of the things that I want to circle back around and start showing again is install methods. In particular, I think it was in one of the last couple of releases, we've made some changes with like the agent-based install, as well as the, I call it the self-contained install, but which is the one where you pull down an ISO and you boot the nodes to an ISO. You give them it uses curses, right? You give them an IP address for each node. If you need to, you can use DHCP. And then you tell them the rendezvous IP, which is effectively where the API endpoint is. And then they all go and point at that thing, and then it stands up basically the assisted installer interface. So you from there, you go through and you tell it what the cluster name is and what the domain name is. And just like if you've ever done assisted installer before, the nodes pop in and you say, oh, you're a control plane node and you're a compute node. And all of that stuff, and you click go, and it deploys a cluster, and it's entirely self-contained. So no external registry is needed or anything like that. I really want to show off that install method.
Yeah.
I think that's really cool.
Yeah, that is cool. That would be awesome to use. Hell yeah. And we got a bunch of stuff to revisit too anyways, right? Like we got to go back through and we got to do like a get back to basics kind of series, right?
Yeah.
Like,
oh, I started to dig through networking and all of the changes that have happened in networking over the last 4 releases with UDNs and BGP and like all of these other things that are happening inside of there, and it's there's a lot that's happened.
yeah.
Yeah, we definitely need to go back and revisit those. So for anybody who's listening, again, either live or after the fact, if you have like a request for like how we prioritize, how we order those things, like, hey, like, I really want to hear about this thing because I haven't heard much about it, let us know, and we'll be sure to prioritize those. Is OpenStack dead? No, it is not.
No.
So OpenStack has, as far out as anybody does roadmaps, it has a long roadmap ahead of it in that regard. It is still really well suited for the things that it's always been well suited for, right? We have a lot of folks in telecommunications and stuff like that use OpenStack. Generally speaking, I think the stance that you'll find from Red Hat is we favor or we encourage folks to consider OpenShift virtualization first. And if that doesn't meet their needs, or if their needs are better met by OpenStack, then consider OpenStack. So it may feel like, if you're going out and talking to your account team and you're like, yeah, I want to do virtualization. And they say, oh, OpenShift virtualization. And you say, yeah, but really, I feel like OpenStack is a better fit. It may feel like they're resisting you or they're pushing you back or saying otherwise. That's just because we tend to have that favor OpenShift because that's where a lot of the new features, capabilities, and I don't want to say OpenStack isn't exciting, but the excitement is happening.
Yeah.
Yeah, OpenStack is not going anywhere. I will point out that with OpenStack, is it 18 or 19? I think it's
Don't get me
19.
lying.
I think it's 19. We now have it's OpenStack on OpenShift. So even if you're using OpenStack, you still have to know OpenShift well enough because the OpenStack, I'm going to say control plane as a general, but basically all of the what used to be called the undercloud now runs in OpenShift. So you still have to know OpenShift to do OpenStack. There's a lot of really cool stuff that comes with that, but yeah, it is a thing.
Yeah.
If you're going to be at Summit this year, I think we're going to have a OpenShift on OpenStack lab, so you can go and get hands-on with it if you'd like.
Nice.
Just looking at the last bit of the chat here. I don't see anything popping out. So yeah, we will see everybody in 1 week's time.
Yeah, man.
Yeah. Any last thoughts, Johnny? And then you want me to click the button for the thing?
I can click it. I've already got my hand on it.
Okay.
I'm over like jumping at it. No, it's good to see you again, man. It's good to be back. And I love having people coming in that are actually like doing this, like having Chris come in and do the stuff with COCO and actually talk about stuff that they're doing with it and stuff like that, instead of, not that the product team isn't cool or anything like that, but it's a different perspective to have somebody that's actually, doing it for customers and, scar tissue and all that stuff. So, and yeah, I think it really showed tonight, and that was awesome.
Yeah, agreed. Thanks everybody for joining us. Thanks for hanging on for a better part of 2 hours. And thank you for all of the chat. We appreciate all the interactivity. Thank you all.
Yeah, for sure. Cool.
All right. I'll see you next week, Johnny.
Later.